In this video, we're going to be talking about Newton's second law of motion. Newton's second law of motion states that the force is equal to the mass times the acceleration of an object. Here is the formula that we usually know. Force equals to mass times acceleration. Now, the acceleration of an object depends upon two variables, its net force and its mass. The acceleration of an object is directly proportional to its force. So let's say if we apply a little bit of force, the object is only going to move just a smidge, a tiny bit of distance. Now, if we apply an even bigger amount of force, it's going to move a whole lot more. It's going to move even more. Even though these both balls have the same mass, it only depends upon its force. It is directly proportional to its force. The bigger the amount of force that we apply on an object, the more its acceleration is going to have. Now, on the other hand, acceleration is inversely proportional to its mass. Let's say you have two balls of different sizes and different masses, and you want to apply the same amount of force. If you apply just a little bit of force, the bigger ball is going to move a whole lot slower, and the smaller ball, it's going to move even faster. It's going to have a lot more acceleration than the bigger ball. In simpler words, the bigger the mass of an object is, the less acceleration it's going to have. Because if it's a lot of mass, it's going to move slowly. And then if you have a small amount, it's not that hard to make it move fast. That's what it means. The bigger the mass, the lower the acceleration, and then the lower the mass, the more acceleration that you have. Now, talking about the force is directly proportional to its mass. If you have a huge object, of course it's going to apply a much bigger force than if you have a smaller object. And now on to the experiment.
We will need first three objects. These two will be making the little ramp, and in here we will place the object which will be moved by the three little balls of different masses. So first, the little ping pong ball. So we here see that the little sharpener didn't move at all. Then the second ball. Here we see that the sharpener moved slightly more than with the ping pong ball. So here we will place another time the sharpener, and we will use now this one. So now we see that the sharpener moved more than with the two others.